we solve one example on solving the system of linear equations. So here is a set of linear equations: x plus 2y plus 3z is equal to 6, x plus 2y plus 2z is equal to 5, and x plus lambda y plus 3z is equal to mu. So lambda and mu are constants. We need to find it such that these set of equations possesses a unique solution, or infinitely many solutions, or no solutions. So here we write the augmented matrix. You note that the first three columns 1 2 3, below that 1 2 2, and below that 1 lambda 3. So first three columns to the left of the separator are coefficients of x, y, and z respectively. That is the coefficient matrix A. And the right hand side on the separator is the column B with constants 6 5 mu. So this is called as augmented matrix. In other words, we are augmenting the matrix, coefficient matrix, by the additional column of constants. Now we retain the first element a11 and make the remaining elements in the first column as 0. So we don't bother about the remaining elements in the matrix. We only concentrate on retaining the first element a11 if it is non-zero, and make the remaining elements in the first column as 0. So we perform the operations r2 minus r1 and r3 minus r1. So the resulting matrix consists of first row as it is 1 2 3 6, but in the second row we have 0 0 minus 1 minus 1, and in the third row 1 minus 1 0, so lambda minus 2, and the other element is 3 minus 3, it is also 0, and mu minus 6. So this matrix will be in the echelon form if lambda is equal to 2. We don't know whether this matrix is either in echelon form or not. Depending on the value of lambda, we decide whether it is in echelon form or not. So if lambda minus 2 is equal to 0, it is in echelon form, and we have lambda is equal to 2. That is the case. So there may arise two cases depending on the mu value. In the first case, when lambda is equal to 2 and mu is equal to 6, the last row becomes a 0 row. The first element is 0, the second element lambda minus 2 is also 0, third element is 0, mu minus 6 is also 0. So the last element, last row will be 0 row, and the matrix, entire matrix AB in the row echelon form. So it consists of only two non-zeros, therefore rank of A is also 2, and if you consider the entire matrix AB, rank of AB is also 2, therefore the system is consistent. But here rank of A is equal to rank of AB, and this common value is less than 2, less than 3, that is the number of variables, less than 3, the number of variables, hence it has infinitely many solutions. The infinitely many solutions rises because we treat number of variables, that is 3, minus the rank value 2, that is equals to 1. So we treat one variable as the free variable, that is it may take any value or any number, and depending on the value of this free variable, we decide the values of the remaining variables. So as this free variable can take infinite number of values, there will be infinite number of solutions. So when rank of A is equal to A, rank of A is equal to rank of AB, and it is less than the number of free variables, there will be infinitely many solutions. We shall discuss how we can find out the solution in this case, but we are now concentrating only on the number of solutions. whether the system has unique solution or infinitely many solution and no solution. Here in this case, when rank of A is equal to rank of AB is equal to 2 and less than the number of variables 3, therefore the system has infinitely many solutions. In this case, we note that lambda is equal to 2 and mu is equal to 6. And in the second case, lambda may be equals to 2, but mu is not equals to 6. That is, mu minus 6 is not 0. So if you consider in the A part, that is the left of the separator, there will be only two non-zeros, that is 1, 2, 3, and below that one second row 0, 0, minus 1. Only these two are the non-zero rows. But in the coefficient matrix A, there will be 3 rows and 2 non-zero rows, therefore rank of A will be 2. But if we consider the entire matrix AB, that is along with the constant matrix mu minus 6 in the last entry, but mu is not equals to 6, so mu minus 6 is not equals to 0. Therefore in the entire matrix there will be 3 non-zero rows, and therefore rank of the entire matrix AB is 3. And here you note that rank of A is less than rank of AB, or rank of A is not equals to rank of AB, therefore there will be no solution. In another case, in the third case, if lambda is not equals to 2, of course mu may be not equals to 6 or may be equals to 6, we will consider only lambda not equals to 2. In that case, you may note that the last row will not be a 0 row, and it is also the entire matrix is not also in the row echelon form. So we change R2 to R3 and R3 to R2 to write the entire matrix in the echelon form. And after writing it in the echelon form, you may note that as lambda is not equals to 2, lambda minus 2 is non-zero, and this minus 1 in the third row lies to the right of the leading non-zero element in the second row. Therefore there will be 3 non-zeros in A part also, and if you consider the entire matrix AB, there will also be 3 non-zero rows. So rank of A is equal to rank of AB is equal to 3, and as number of variables is also 3, this common value is also equals to 3, therefore there is only unique solution.